Okay, so this is the first question on the impulse packet. But before I get into that, I want to just quickly cover something I forgot to mention in the last video. Pretty important. Um, this formula, which I wrote down earlier, which is this force times the change in time, which is equal to the initial minus or final minus initial. This left side of the equation is the impulse, and the right side is the change in momentum. So when the packet is literally titled impulse and momentum, it's talking about this equation, right? And the left side is the impulse. So that's just the force times the time it is applied for. And that can be seen like a baseball bat. So like the impulse of the swing, for example, is going to be the force that the bat is swung with times the amount of time the bat is touching the ball, right? That is going to be the impulse the bat is applying onto the ball. So, and usually impulse is a quick, kind of snap, like it's an impulse, right? It's a short amount of time. So it's supposed to be kind of like an instant. So the instant the bat touches the ball is gonna, leave and gonna fly back the other way, and it's gonna not touch the ball anymore, right? The small impulse that the ball is in contact with the bat, the force that is applying in that instant is the impulse, if that makes sense, right? So it's supposed to be a quick amount of time, and that's just kind of what this left side of the equation is referring to, right? That quick impulse. So, um, let me just actually solve this problem now. So again, I'm gonna just kind of use that formula I was just talking about, where it was F T equals P F over P initial. And for this question, looks like a G, we are comparing the time, right, between car M and car 2M. And the most important part of this question as a whole, in my opinion, is the braking force being independent of mass. And I'll get to why in a second. Essentially, though, all we're doing for this equation is we're going to be comparing the formula that we give for M compared to this formula for M, or 2M, sorry. So to rewrite this formula, we don't know the force, but I'm going to just put F for force times the change in time, and I'm going to put time 1 to refer to the time that the first car takes to stop. And this impulse is equal to the, this should be, sorry, should not be equal to each other. It should be minus, it should be P initial, or sorry, P final minus P initial, not equals, my bad. F times the change in time is equal to the final. The final for both cars is going to be 0 because obviously the car is going to come to a stop um, at the end, so the velocity is going to be 0. And like I mentioned previously, P is just equal to mv, so it's going to be minus mv for our initial momentum. The same can be said for the second car, which is going to be time 2, which is again going to be stopping. So it's going to go to 0 minus 2mv because the m is twice as big, right? Double the mass. So now we're going to compare these two equations. You could be able to just kind of add them up to each other or something, but I just divided it. So it's divided by f change in time 1 is equal to 0 minus mv. This made more sense to me, just because we have to cancel a lot of stuff out. And that's why I mentioned the braking force being independent of mass is important. If the braking force was reliant on the mass, then the braking force, this is force, by the way, like this F is force, it's the same force that's in F equals ma over here, right? If it was different depending on the mass, then the force up here would be like force 2 compared to force 1. But since the force is the same regardless of the mass, we're able to just kind of cancel it out like that, so we don't have to worry about force, right? Because we don't know it, so we're going to just cancel it out. I'm also going to cancel out m and v because the mass, this m refers to a certain mass, and that is the same between both cars. It's just this 2 is the thing changing the m for the heavier car. But ultimately, m is the same thing, so we're going to cancel out m. And the velocity is the same as well, because it doesn't give us a second one. It says it's the same speed, right? They both travel at v, so I'm going to cancel that out as well. So then we are left, we have 2, it's like a negative, so they also cancel out, I think, right? Is that how negatives work? I'm pretty sure if it's divided by, yeah, I don't even care. It doesn't even matter for this question. There's no negative in the final answer, but if there was, it would not matter. I'll get to why in a sec. Anyways, change in time 2 over change in time 1 ends up just being 2, which is all we kind of have left here. And then to solve for change in time 2, which is kind of what our final answer is going to be, we just bring this over to the other side, which becomes t2 is equal to 2t, because this goes over here, it's technically 2t1, And this is your final answer, and that's why the answer is D. The reason why I said the negative sign does not matter here, is because yes, it is a vector, but this is talking about speed, and speed can't be negative either way. So like that's how I knew, okay, it can't be negative 2t, right? So I'm gonna just make it positive. If the question is talking about momentum or like impulse, that has direction. So if you get like a negative momentum, that means it's going in a specific direction. But for speed specifically, it's fine. So that's why I didn't sweat. But if this was a momentum and I was like, "Oh shit, is it minus or not?" Then I would have been cooked and it would have to actually be correct. In this case, though, I can just kind of assume, okay, there's no negative because it's speed. It can't be negative, right? So I got 2C. Um, I think the hardest part is just recognizing that you have to do the whole division thing. I mean, there might be a way to just kind of like set them equal to each other and like, minus things and move them around. But personally, I found it easiest to just divide in this scenario since we're looking for time. We have everything else. We're just going to kind of compare it by canceling things out. Um, that should be it. This is not that hard of a question, but it is kind of a unique question in terms of the whole division thing. So I doubt we'll see stuff like this on any tests. But yeah, pretty simple stuff.